Okay, we're going to deal with a little bit of a word problem here regarding growth and decay. So we have our Science Olympiad team at Huntley High School use their microscopes to determine the initial amount of 62 bacteria on a toilet handle in the boys' restroom. Kind of gross. Upon further investigation, it is determined that it triples every hour. So it tripling every hour. This right here is our multiplier. We know it triples. So what happens every hour? What happens every minute? It doubles, it triples. So 3 is our multiplier. So we're going to use that when we create our equation. And our equations, so if we look at A, we're going to do that first, is going to be of the form A times B to the x power, where B is our multiplier, A is our initial amount, x is generally time, but how long are we evaluating? So I'll put time up there because that's generally what it's going to be. So let's do A first. So A, find the number of bacteria on the handle after 3 hours. Well, we know we start with 62. So I'm going to take 62 times our multiplier, triples. I'm going to do this after 3 hours. Okay? So 3 hours, triples, starting with 62. This is going to tell me approximately how much bacteria after a 3-hour period. So this is part A. So I'm doing that same thing for part B. The initial value doesn't change, the multiplier doesn't change, but now we want to know what happens after 5 hours. Well, we can see the tremendous growth in a 2-hour period. In 3 hours, it took us to get to 1674. But now, only 2 hours later, we're already in the 15,000 mark. So we can see how quickly it grows when we're dealing with an exponential model. And so exponential model, either growth or decay, is going to create a rapid growth or a rapid decline. And so ideas like bacteria and actually investing money, a lot of those are considered exponential type situations.